let's look now into an example. This is a curious example. You'll see what I mean. So we are given the function f of x, that is the sine of 1 over x. And let's try to find the limit as x tends to 0 of f of x. Now, notice something. Here we cannot just plug 0 in the function because f of 0 is not defined, okay? It does not exist because we have 1 over 0. That's no good. Okay. So what do we do then? So let us just, let's try a few values, see if we can form a guess about what's going to happen. So let's take, let me draw a trigonometric circle. There we go. So let's take, for example, a value that is simple. So we are able to compute the sine of pi, right? The sine of pi is 0. So let's say we take 1 over x equal to pi, or x equals 1 over pi. I'm picking this one because then it's easy, okay? So f of 1 over pi is the sine of pi, which is 0. Okay, we would be in this point over here. Okay, that would be pi. This would be my x equals 1 over pi. Okay. But then we could keep going. Okay. We have 0, we have pi, then we can have 2 pi, and so on. So it goes like this. Okay. So we can take, so it would be 1 pi, 2 pi, 3 pi, 4 pi, and so on. Okay. So we can take k times pi divided. Okay. And then this k will be, well, it could be, as we were saying, it could be 1, 2, 3 times pi, 4 times pi, and so on, okay? But we could also decide, well, let me go backwards. Okay, so we could also go backwards, and we could do with negative pi, okay, or negative 2 pi, negative 3 pi, and so on. So actually we have the plus and the minus, plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, and so on. But we could also decide, okay, let me stay where I am. Let me take 0 pi. Okay, so the 0 would be also, no, the 0 is not good. I'm sorry about that. Remember, when we have a 0 here, we have a problem because it's 1 over 0. So that's it. Okay, you see, we have taken into account all the possible values. So it's plus minus 1, plus minus 2, plus minus 3, and so on. Now, notice what happens here. So we have 1 over k over pi, okay? And what happens when k tends to infinity? When k becomes large, what happens to 1 over k pi? It goes to 0 because we are dividing by something larger and larger and larger, okay? So these are my values of x. X gets closer and closer to 0. Okay, so we could guess, well, f of 1 over k pi, this is the sine of k pi, this is 0. So we could guess that the limit as x tends to 0 of f of x is 0. Okay, this could be this could be true because this is so many values. For every value of k, we have found a sequence of x's that tend to 0 and f of x goes to 0 too. So this is a possibility. So maybe 0 is the limit. Okay, but here let's be careful because we could take a different approach. So we could take, for example, instead of 1 over pi, it's also convenient if we take 2 divided by 2k plus 1 pi. Okay, and here let's take k plus minus 1, plus minus 2, plus minus 3, and so on. Okay. In this case, if we look at it in the trigonometric circle, what values am I talking about? I'm talking about the top and the bottom. Okay. So these are the angles that are like pi over 2 plus k pi. Okay. So this is the 2k plus 1 pi divided by 2. Which is what we have here for x, only that is inverted. Okay. So again, we can take one term and we can keep going. Okay, so we can any once you have one value that works, you have that value plus any number of terms that you want. Okay, so notice what happens here. This value 2k plus 1 pi, when k becomes large, it also goes to 0. Okay, so I could say, well, let me plug it in the function and let's see what happens. So this is the sine of 2k plus 1 pi divided by 2. And now what happens here? So notice in the circle, the sine of 2k plus 1 pi sometimes is 1, sometimes is negative 1. Okay, it depends on how many times, if the k is even or odd, basically. Okay, so it is plus 1 if k is even, and it is negative 1 if k is odd. Okay. And that's pretty much it, because we have a bit of a problem. So the limit cannot exist. Before, we found a sequence of x's that approached 0, but then it looked like f was always 0 on that sequence. But now we have found another sequence that sometimes it's always 1, sometimes it's always negative 1. So what is the limit? So we have the problem because we can always find one of these values that is as close as we want to 0. And the value of f can be 0, can be 1, can be negative 1. So the limit cannot exist. Okay. The problem is that the result is different depending on the sequence of x I choose. Okay, and I wanted to discuss graphically what's happening. So this is the graph of sine of 1 over x. You see that and near 0, it becomes a little crazy. So what's the problem? What's happening here? So the first time, let me use color. The first time we were approaching, let me use a color that we can see better. We were approaching using this sequence of points. Okay. You see where x equals 0. And it looked like the limit would be equal to 0, right? But based on this graph, doesn't look like that, because it keeps oscillating up and down. The second sequence that we found actually was for these top values. You see here. Okay, these were 2 divided by 2k plus 1 pi for k even. And then we had the bottom ones. Okay, these are x equals 2 divided by 2k plus 1 pi for k odd. Okay. So you see, this is a big problem, because actually you pick any number between -1 and 1. Let's pick 1/2. Okay. There we go. There is always a sequence of values, okay, that approach 0, and for which the limit is the number we chose. So in this sequence, f of x is 1/2. Okay. So you see, there is no chance. Okay, the problem is that the function sine of 1/x assumes all the values between -1 and 1 infinitely many times as x goes to 0. Okay, so it will never stop oscillating. It just starts oscillating faster and faster and faster, so that there's no chance. So the limit does not exist. And this is a very important example to keep in mind, just to know the things that can fail.